Alright, hello everyone. Welcome to my YouTube channel. So, in continuation of our discussion on geometrical progression, we are going to look at a sum of geometric progression to infinity. That's if you have a geometric series. Remember, we said the difference between series and sequence. When you have a sequence like this, instead of using comma, you just use the sum of it. You call that one a series. But if we now separate each term by commas, we call that the sequence. Okay, so now here we're saying that sum of a GP to infinity. That's what we call sum to infinity, which is written like this: S infinity. Now we said that this is given by the formula A all over 1 minus R. And where is this gotten from? So you discover that from the formula of sum of a geometrical sequence, we are told that Sn is equal to A into 1 minus R raised to power n all over 1 minus R. That is when our R is less than 1. So we're saying, assuming you have a situation where the absolute value of R is less than 1, that means minus 1 is R is greater than minus 1, and then my R is less than 1. Okay, so if you have a situation like this, that means your common ratio is in between these two numbers. The implication of that is that if you take R to any power, it will still be less than 1. And so, and as your n is tending to infinity, as your n is increasing, the number of your n, remember you're summing n. Maybe you're summing the first 5 terms, the first 10 terms, the first 20 terms, 100 terms. As it keeps increasing, the value of this will be reducing towards 0. So as n is going towards infinity, R raised to power n will be going towards 0. Since your R at every time at under this condition is a fraction that is less than 1, and so you will see that if this guy now tends to 0, so what happens is that you are going to have just a multiplying 1 here, and that is what gives our S as n goes to infinity. This n here will now go to infinity, so it will now be equal to, here we have only 1 left, times a, we'll have a all over 1 minus R and K, and that's how we got this particular formula. Okay, so here we have some quick examples to look at. Okay, so I'm going to just take the first one here, and I'll allow you to do the second. If we are to do example A now, what is our R? Remember, we are asked to find the sum to infinity of the series. So first of all, write our formula, which is, and so our A in that the series of A is 6. That's 16. That's the first term, all over 1 minus our R. Remember, your R is a term divided by the previous term, and this is going to give us 1 over 8. So this will be 1 over 8. If you subtract this, 1 minus 1 over 8 will give you 7 over 8. That's going to give us 128 all over 7. And that is your sum to infinity. And if we would want to do the second one here, just find your common ratio, which is divide this by the previous. And the term here is not half. The term here is minus half. So you should take note of that. So if you divide negative half by 1, that will give your R as minus half. And then you solve to get the value you're looking for. So let's go to example 2. Example 2 here says that we are given the sum to infinity of a geometric series as 100. Okay, and then we are asked to find the first term if the common ratio is this. So that's another way that this question can come, and we can as well give you the common ratio and ask you to find the A. So all you need to do is, assuming we want to start with the A part, so we have that S infinity is equal to A all over 1 minus R, and your S infinity has been given as 100. And so we're going to have 100 is equal to, we are asked to find A, which is the first term. So A all over 1 minus our r here is 1 over 4. And so here we're going to have 100 is equal to our a all over 1 minus 1 over 4 will be 3 over 4. And so if you cross multiply here, our a alone will be equal to 100 multiplying 3 over 4. And when 100 multiplies 3 over 4, you are going to have 75 as the value of your A. Okay, and we can take the C part. So let's take the C part. The C part says we should do the same if our R is minus 1 over 4. And so our formula, and so 100 is still our S infinity, and our A all over 1 minus 1 over 4. And that's going to give us A all over 1 minus will be plus, which will be 5 all over 4. And so if you cross multiply this time, it means that our A alone is going to be equal to, remember this is over 1. So our A alone is going to be 100 multiplying this, and that is going to give you 125 as the value of our A. I left the B for you as an exercise. It's a very brief lesson, and that's where we're going to stop. Kindly subscribe to our YouTube channel, like, make comments, and share our YouTube videos. We'll see you in our next video. Bye.